Alright, so we're going to look at systems of three variables. So in order to solve these, we have to do a little bit more than we would if we were just solving a system of two variables, just because there's three letters, so there's three unknowns that we have to find. So the first step that you're going to do is you are going to use a pair of the original equations to eliminate a letter. So use a pair of equations to eliminate, it's an a letter or a variable. Okay, so if we look at what we have here, it looks like z might be z or x, or y. Really, any of these variables we could eliminate. Let's go ahead and let's eliminate z. So we're going to take these two equations, that's our pair of equations, and we are going to multiply one of them by something so that when we add the two equations together, the z's will cancel. Which it looks like for the top equation, I'm going to multiply that by 2. So let's times that by 2. So we will get for our new equation, let's see, we'll do it right here, 2x minus 4y plus 2z is equal to 10. And then we add the two equations together. So that'll be adding this equation and this equation. So we will get, when we add those together, 3x minus y, the z's will cancel, equals 5. Okay, and there's one of our equations that we're going to use. So the second step would be to use a different pair of equations to eliminate the same variable. So use a different pair of equations to eliminate the same letter. Alright, so this time let's go ahead and we need to eliminate z again. This time let's use the first and last equation. And I'm going to multiply the first one by, looks like -4 will do the trick. So if I write my two new equations, well, I'll write the new one down here. That will give me -4x and then plus 8y minus 4z is equal to -20. Okay, so I am going to add the last of the original to my new equation. And when we add those up, we will get -2x and 6y, and then the z's cancel, and that'll just equal 2. There's my second equation that I'm going to use. So now, as you can see, we've got just these two equations. So this one, and it's now a system of two equations which we know how to solve. So our third step would be to solve the system of two equations. Which basically means that we would just start back up at step 1 and use a pair, or use those two to eliminate one of the letters. It looks like y might be easy to eliminate, so let's go ahead and let's eliminate y. So I'm going to rewrite these two equations down here. So 3x minus y equals 5, -2x plus 6y equals 2. Okay, so let's multiply the top one by 6. That will give us 18x minus 6y equals 30. And when we add those two together, we will get 16x, y's cancel, equals 32. Okay, when we divide by 16 to solve for x, we get x is equal to 2. Okay, great. So now we can back substitute that, and for one of these two equations to figure out what y is. So let's just use the top equation. So we'll have 3 times x, which is 2, minus y equals 5. So this is, of course, 6. When we subtract 6 from both sides, we'll get negative y equals negative 1. So y must equal 1. Great. Now, the last thing we have to do that we didn't have to do if we were solving a system of two equations is to plug both of these values in to one of our originals to find the third variable. So we've got 2 and 1, so let's look back up at our original equations. Okay, so let's use this top equation right here. Let's move it down. Let's move it down. Let's move it over here. Oops, I kind of turned it. Okay. So let's see, 2, 1, okay. So x equaled 2, y equals 1. We don't know what z equals. So we'll have 2 minus 2 plus z equals 5. So that will give us z equals 5. So if we look at our solutions, we have 2, 1, and 5. And if we wanted to check and make sure that's right, you just plug those into all three equations and see if they add up.